Hi, in this video we are going to solve a few more equations and talk about some special cases, and then we're going to also talk about how we classify an equation. So the first one that I have set up here, we would just solve like we have been. First, I want to get rid of my parentheses. So on the left-hand side, I'm going to distribute this 3 through my parentheses. And on the right-hand side, I'm going to distribute the -2. Remember to keep your negative with the number to the left. So over here, I have 3 times 2x gives me 6x. 3 times -7 gives me -21, then plus 4x. And on the right-hand side, I have -2 times 4x is a -8x. -2 times a +3 is a -6 plus the 10. And now notice that I did not distribute to the number here. I only distribute to what's in parentheses. Now, before I start moving things to one side or the other, I'm going to look on each side of the equation and combine any like terms. So on the left-hand side, I see I have a 6x and a 4x that I can combine to give me 10x. I have a -21, but nothing to combine it with on the left-hand side. On the right-hand side, I have a -8x, nothing to combine it with. And then -6, +10 combined to give me 4. And now we're ready to get all our variables on one side, all our numbers on the other. I'm going to start off by adding 8x each side. Please keep in mind there's several different ways you can approach this problem. The -8x, the +8x cancel out, and I'm just left with 4. On the left-hand side, the 10x and the 8x became 18x, and I still have the -21. Now I want to move my 21 over, so I'm going to add 21 each side. The -21 and the +21 cancel out, so I'm left with 18x. And on the right-hand side, 4 and 21 make 25. For my final step, because I'm multiplying x by 18, to get rid of the 18, I divide by 18. Remember, anything over itself goes to 1, so I'm left with a 1x and 25 over 18. And that's as simple as I can make that answer. Now, this is nothing new. We've done examples like this in the past. This is our solution. We can plug it in and check it. What is new is how do we classify our equation? If we come up with a solution, okay, so if we derive a solution, then we classify our equation as being conditional. And now I like to think of it this way. Underneath this condition, this is the solution. So this equation is conditional. This will be what happens most often is we have an equation, we solve it, we come up with an answer, and we would classify it as conditional. Now we're going to look at 2 special cases. When we first look at this problem, it looks very similar to the last one, and in fact, we would start it exactly the same way. I'm going to get rid of my parentheses. On the left-hand side, I'm going to distribute the 4. On the right-hand side, distribute the -2. 4 times -3x minus 12x. 4 times 4 is 16 minus the 6. On the right-hand side, -2 times 3x minus 6x. -2 times -8 is a +16 minus the 6x. And now remember, before I try to start moving things, I'm going to combine my like terms on each side. I have a -12x. I can't combine that with anything. I have a 16 and a -6. Those can be combined to give me +10. On the right-hand side, I have a -6x and a -6x. Those are going to combine to give me -12x. And then I have a +16. Now, at this point, you might notice that something funny is going on. but most of the time students are in solve mode and they just keep going. So let's pretend that we want to get rid of our minus 12x. So we're going to add 12x each side. Well, what happens? On the left-hand side, minus 12x, positive 12x cancel out. On the right-hand side, minus 12x, positive 12x cancel out. And what I'm left with is 10 equals 16. Huh? How did that happen? Well, your first instinct is that you've done something wrong, but in reality, we have not. This is not new math. 10 is not the new 16. What we've ended up with is what I like to call nonsense. It doesn't make sense at all. So when we end up with nonsense, our solution is going to be that there isn't one. In other words, we'd say no solution. And if we're asked to classify our equation up here, we call this a contradiction. And that makes sense, right? A contradiction is when we say something contrary to something else. So when we end up with two things that aren't equal, saying that they are equal, it's a contradiction. So we classify the equation as a contradiction, and the solution is there isn't any. And typically we say no solution. One more example in special case. Again, looks very similar to what we've been doing. We would distribute the 3 on the left and the negative 5 on the right. 3 times negative 3x minus 9x. 3 times 7 is a positive 21 minus the 12. On the right-hand side, we would have negative 5 times 3x is a minus 15x. Negative 5 times a negative 2 is a positive 10. And then we have plus 6x and a minus 1. Again, I'm going to combine my like terms on the left and the right. On the left, I see I can combine the 21 and the negative 12. Nothing to combine the minus 9x with, but 21 minus 12 would leave me a positive 9. On the right-hand side, I have a minus 15x and a 6x. They would combine to give me minus 9x. And I have a 10 and a minus 1. They combine to give me 9. Now again, at this point, you might notice that something different is going on. And that is that we have the same thing each side. But if you don't notice it and you're in solve mode, again, let's add 9x each side. Well, the minus 9x, positive 9x cancel out. The minus 9x, positive 9x cancel out. And now we're left with 9 equals 9. Notice that this is different than the last problem we did, in that this is actually true. 9 is equal to 9. All right? So as soon as you realize you have the same thing, whether you realize it up here or down here on each side of the equal sign, then we would say that our solution is all real numbers. There isn't just one solution in this case. It's every number we can think of. In other words, I can plug in 1, this is going to be true. I can plug in 1,000,000, this is going to be true. I can plug in negative 2.76, this is going to be true. So any number I can think of, if I plug it in, it's always true. Why? Because we have the same thing on each side. And if we're asked to classify the equation, we call this an identity. Think of it this way. When we look in the mirror, we see our identity, right? We have the same thing each side. So I hope in this video you've realized that when we solve an equation, when we derive a solution, we can classify the equation as conditional. If we end up with nonsense, we state that there is no solution, and we classify the equation as a contradiction. And if we end up with the same thing on each side of the equal sign, Our solution is all real numbers, and we classify the equation as an identity.
To see what condition my condition